Welcome back to The Explainer. Today, we're doing a bit of a cosmic reality check. We hear the term light year tossed around all the time, right? And yeah, it sounds incredibly vast. To our human minds, it absolutely is. But today, we're going to completely shift our cosmic perspective. We're breaking down some absolutely fascinating insights from a recent deep dive by science writer Joe Smonest into the true scale of the universe. And trust me, it's going to challenge literally everything you think you know about distance.
Okay, let's dive right into this. Compared to the rest of the universe, traveling a single light year is, well, it's barely more than the first step out your front door. I absolutely love this metaphor from our source material because it takes this completely unimaginable, mind-bending scale and grounds it in a relatable, everyday reality. I mean, think about your own front door for a second. You take one step out. You haven't reached the sidewalk. You definitely haven't reached your neighbor's house. You've barely moved at all. And that is exactly what one light year is to the universe. It's just the threshold. So that brings us to the central, really mind-bending question for this explainer. If we were to pack up a spacecraft and just launch ourselves into the abyss right now, how long would that journey actually take? How much time, effort, and engineering does it take to just make that single metaphorical step out of our solar system's front door? Well, let's launch into it and find out.
To figure that out, we have to start with Section 1, Current Reality, our fastest spacecraft.
Now, what's really interesting here is looking at a direct contrast between our two most notable mechanical explorers. On one hand, you've got Voyager 1. That's our most famous interstellar probe, and it's currently pushing further out into the unknown than literally anything else we've ever built. On the other hand, there's the Parker Solar Probe, which is our actual, undisputed fastest spacecraft. But our source material points out a pretty sobering reality. Voyager 1 is traveling at roughly 38,000 miles per hour. Which sounds fast, right? But at that speed, it would take over 70,000 years just to travel a single light year. 70,000 years! Now, the Parker Solar Probe is way faster, hitting a staggering 430,000 miles per hour. But even if we push the absolute limits of chemical rockets, at that mind-bending speed, it would still take over 1,500 years to cross just one light year. So, in the grand context of the cosmos, our absolute greatest achievements in speed are moving at a total crawl.
And because our current tech is basically crawling, we have to look ahead to Section 2, the theoretical future, pushing the limits.
And this brilliantly illustrates the massive conceptual leap we really have to take. When you stack up Voyager 1 and the Parker Solar Probe, our current reality, against something like the Breakthrough Starshot concept, it's night and day. Breakthrough Starshot is a radical, theoretical departure from traditional rockets. It completely abandons heavy fuel tanks. Instead, the idea is to use ground-based lasers to propel these tiny microchip-sized light sails. The projected speed? Get this, 20% the speed of light. That is over 134 million miles per hour. At that theoretical speed, the journey of a single light year drops from thousands of years down to just 5 years. 5. It just completely highlights the massive gap between what we're doing today and the groundbreaking theoretical leaps we'd need to conquer cosmic distances in a human timeframe.
But let's slow things down for a second and look at Section 3, Surviving the Emptiness, Hazards of the Void.
Let's see how this builds, because our source lays out these specific dangers as a series of horrifying, sequential hurdles a spacecraft has to face as it leaves Earth behind. Step 1 is energy. How in the world do you keep a spacecraft powered when you're entirely cut off from the light and warmth of any star? Then, Step 2 is radiation. See, the space between stars isn't actually perfectly empty. It's filled with high-energy cosmic rays that will relentlessly bombard any vessel. Step 3 is communication. As you get further and further away, sending a simple message back to Earth takes so long that the signal eventually just fades completely into the background noise of the universe. And finally, the ultimate hurdle, Step 4, sheer emptiness.
Which begs this honestly terrifying question. What would you actually see along the way? Our source material leans heavily into the real terror of the void here. Above all else, way more than the threat of radiation or some catastrophic energy loss, the sheer emptiness between the stars is the ultimate psychological and physical hazard. You wouldn't see streaks of starlight zipping by like you do in the movies. No, you would just be surrounded by absolute, unfathomable blackness for billions and billions of miles. No landmarks, nothing to look at, just the void.
Okay, let's accelerate to the finish line with Section 4, the arrival, just scratching the surface.
So the crucial point here all comes down to the number 1. Imagine you actually endure it.
Imagine you survive the energy crisis, the radiation, the total isolation, and that terrifying emptiness. You've finally crossed that metaphorical finish line. Whether it took you 1,500 years on the Parker Solar Probe or just 5 years on a theoretical laser sail, you've traveled exactly 1 light year. And the awe-inspiring, honestly kind of crushing reality is that you still haven't even reached the closest star. You're still completely alone in the dark. A journey of 1 light year, which is an unfathomable distance to us, requiring either millennia of travel or entirely new theoretical physics just to survive, basically means you have barely scratched the surface of the cosmos.
It's a deeply humbling realization about the true scale of our universe, isn't it? Which leaves us lingering on this final, really provocative thought directly from our source material. Would you embark on a journey like this if you could? Knowing the terrifying hazards, the absolute isolation, and the stark reality that a literal lifetime of travel barely gets you off the cosmic porch, would you take that first step out the front door? Think about that scale for a while, and I'll see you in the next explainer.